That's true, Dr. Zayas. Very well.
Where would we be without THC? 'Cause we know they're lying to us, just don't know to what degree. Yeah, where would we be without THC? The Higherside Chat Show, Greg Carwood Company.
All right, Higherside Chatters, as we continue to unravel the reality onion, we find ourselves turning to the alternative for paradigms and possibilities that provide better explanations in areas the mainstream has steered us wrong. And when we're talking about the sciences and our understanding of space and what makes up our reality, one idea I keep coming back to is the electric universe. In a nutshell, it proposes that electricity, not gravity per se, is the primary operator in our universe. And when you dig into the widespread implications of that and how it relates to many different aspects of the human story, it can be quite compelling. You might remember the show we did with David Talbot, where he told us much about the electric universe model, the plasma discharge patterns that would have been seen in the ancient sky, and how this very well could have been the basis for ancient mythology and the symbols we see in many petroglyphs around the world. Well, lucky for us today, we have Wal Thornhill here, the other half of the electric universe equation, whose expertise is the scientific explanations for why the electric universe model makes the most sense. Wal received a degree in physics at Melbourne University in 1964 and began postgraduate studies with Professor Victor Hopper's Upper Atmosphere Research Group, and he's been studying these things ever since. He's the co-author of the books The Electric Universe and Thunderbolts of the Gods, both with David Talbot, as well as the co-founder of the Thunderbolts Project, the main hub for all things Electric Universe, and he's given several impressive lectures and presentations on the topic as well. It's an honor and a pleasure, and I can't wait to dive into it. Wal, my man, welcome to the Higher Side.
Thanks very much, Greg.
Yeah, thanks for doing it. I do find all the things on David's side of the coin to be very interesting. I think the case is strong for plasma discharge displays in the ancient sky being a major influence on the people of that day and their stories we refer to as mythology. Mm-hmm. But if the science isn't there to support it, then it all kind of falls flat. So I'm anxious to hear the case made from your perspective. And I guess to start, we should probably give the people a bit of a refresher. So can you define the electric universe paradigm for us and maybe contrast it with the conventional views? How do you typically break people in?
Well, I think the thing to remember is, and this goes back to the fact that we're not really taught the history of science. It's just a story which makes us look good. But if you go back and look at what some of the great names in the past were saying, they actually were intuitively sensing the fact that electricity played the major role in people, like Newton and Faraday. Faraday himself felt that the electric force would explain gravity eventually, and he said it would be a breakthrough of unimaginable scope. Mm-hmm. And I think he's quite right. The way I came to it was reading Velikovsky's Wells in Collision, exactly the same as with David Talbot. Only I was lucky because before I entered university, I read that book, and that inspired me to follow it up. So when I was at university, I was I think I was the only science undergraduate who was in the shelves of the anthropology section, just pulling books at random off the shelf and reading the stories of, the most ancient peoples on Earth. Mm-hmm. The stories just leapt off the page at me looking at it from Velikovsky's point of view, which is that the solar system does have a recent history and that all of the reverence for planetary gods for the earliest civilizations was real. They weren't just making stories up. The stories were about the activities of planets. Mm-hmm. So I managed to complete my degree and go on. I began postgraduate work, but by asking questions, I was getting hostility. I wasn't getting the answers I was satisfied with. Mm. So I decided that academia was no place for somebody who had heretical ideas, and so I left and joined the computing fraternity with IBM first and then the Australian government. And when I was with the Australian government, I took the opportunity, because I'd travelled the world many times, to meet up with people who I felt had parts of the puzzle. And that included Velikovsky himself. Mm-hmm. And that was an important meeting because he very kindly accepted me and my family, with 3 daughters, and my wife at his home in Princeton.
Wow.
It was only 6 months before he died. And, of course, he would have had no idea that I might pick up the baton that he was to drop shortly after. And I was unaware of that fact too. But the question I put to him was that because the major argument against him was merely one of stating that his work disobeyed Newton's laws, what was it that we didn't understand about gravity?
Yes.
He had actually thought about that and written about it, but he didn't want it broadcast because he had reservations about it. And in fact, the basic idea, I think, came from one of his daughters. But it basically boiled down to the fact that normal matter, the matter that makes up you and I and everything around us, is made up of neutral atoms. If they weren't, we'd all be electrically charged and be zapping everything we touched. But these neutral atoms themselves are made up of electrical particles, positive and negative, and they can't occupy the same space at the same time. This means that you can actually have atoms slightly distorted by their surroundings, by nearby atoms and the Earth itself. And when they're distorted, they form tiny electric dipoles, which are electrically neutral. However, they do produce an electric force. And it was that he said explained how you can hold billions of tons of water in the atmosphere against the force of gravity, because water droplets, very small ones, are much heavier than the air around them. And he said it's because they are dipolar molecules. In other words, they form tiny little electric dipoles. And in the Earth's electric field, that defies gravity, and so that's why you can have those huge thunderstorms that dump billions of tons of water on you in a few minutes. That too is an electrical effect. In other words, the lightning discharges some of that electricity, and all of a sudden you've got a downpour. So all of these things made sense to me. It was only 2 years later, there was a tiny advertisement in the Scientific American. It was called the Journal of Classical Physics, and the very first article talked about the structure of the electron. Now, this is an idea that particle physicists haven't cottoned onto. They think the electron is a fundamental particle. But this guy decided that no, it was a repeated pattern. It was all particles are made up of orbiting systems of charge. And when you do that, all of a sudden, you have an explanation for both magnetism and gravity. Now, with all of these kinds of simple ideas in mind, it was possible then to look at the work that David Talbot had done, which was quite incredible, really. He spent decades on that, and I spent decades coming from another angle, and we met up finally in 1994 when I rang him in Portland, Oregon, and said, somebody here wants a copy of your book, The Saturn Myth. And he said, well, it's out of print. I told him what I was doing, and he said, have you got something you'd like to present? Well, I'm putting on the first international conference here in Portland. And I said, yes, I have, because I'd been spending some years in England with a group over there who were involved in post-Velikovskian studies, if you like. And I was friends with some of the people working on the scientific aspects. And it was there when I saw what Dave had done, I realised immediately what he was showing were electrical effects between planets, because he was showing Venus in relationship to the Earth and so on. I caught up with him and I said, you may not remember me, but 20 years ago we met at the conference in Hamilton, Ontario. It was the first International Velikovsky meeting, and I'd been invited to that by David's brother, as it turns out. So I said to him, I've seen your work. I think our combined story is far more powerful than either of us trying to work alone, me on the science and you on the reconstruction of the past history of the Earth. And I managed to convince him of that a year or so later when I camped on his office floor for a month in December while the water dripped outside incessantly. And we put on an international meeting in January 1997, it was. And that was the start of the collaboration. Nice. And we thought it would take off very quickly, but it's taken an awful lot of work since then. And I think it was not the time. It certainly wasn't the time. But now we've become, as Dave says, a movement, because qualified scientists and engineers and all sorts of people in all different disciplines are joining us, because this is a science which has no boundaries. You can cross disciplines easily because you can see the connections. once you have a big picture of how things seem to work, everyone can understand it, then they can see what their role could be in furthering what we're doing. And that's one of the most exciting things about it now, that we're actually doing a multi-million-dollar experiment in Canada to show that the sun is not what we think it is. And this all boils down to the fact that if the universe is driven electrically, then stars are not thermonuclear gravitational bodies. In fact, when you look at the idea, you realise just how desperate it was. It was a desperate attempt by scientists a century ago to explain how the sun could keep shining for so long without running out of fuel, because it was viewed as like a fire in the sky, the old campfire in the sky idea, that it had to be self-sufficient. But the electric universe is one of connectivity. Everything is connected. And in the case of stars, they're connected to the galaxy itself by electrical filaments, which connect everything. And they've only just begun to discover them. Radio astronomers have known about them for a while, but the establishment was unwilling to give any credence to the data that had been collected and been analysed by one radio astronomer in particular, Gerard Verschuur, who showed that they could only be explained in terms of plasma, electrical plasma effects. That hasn't yet seeped in. They've found that there are these filaments connecting stars in the galaxy and locally, and they've discovered that the boundary of the sun with the galaxy is odd. It wasn't what they expected. It fitted none of the theories. I think there were about 18 different theories at the time, and not one of them matched, except mine. So this is just sort of an outline of what the electric universe is about. It's about simplification, which is what the scientists of the 19th century were all about. We lost that in the 20th century when we entered an age of neo-Pythagorean, the Pythagoras idea of that you can explain everything in terms of geometry. That's why where Einstein went with his idea of warp space and so on. But that is a dead end, because it describes things. Mathematics can describe things, and it's very powerful. It's very useful. But it can't explain things. So you've got to have the correct ideas in place first and then apply the mathematics, and then it's really powerful, because you can see new ways of looking at things and get information that you would otherwise be inaccessible just by observation. So I went on a bit, I'm afraid, but it's like the old exam question, you have 1 hour, describe the universe and give another example.
Well said. Yeah, I am so curious about it. I do like everything I hear, and I guess a lot of people might be surprised to realize that a lot of things they might consider to be, quote, settled science actually are just kind of ideas that really haven't been backed up in a lot of cases. And I guess I would ask you, what holes are there in the conventional model that the electric universe model fills in?
I should say to begin with that there is no such thing as settled science.
Right.
It's an oxymoron. The electric universe uses quite heavily the peer-reviewed work of plasma cosmologists. And plasma cosmologists have been working in the laboratory for decades, since almost a century ago, looking at the effects of electrical discharges in a very thin gas, or the vacuum of space, if you like. And they were able to show that you can explain galaxies, spiral galaxies, their shape, their rotation, and so on, without even using gravity. When they put gravity into the mix, it made no difference. So it shows you that galaxies at that scale, the electromagnetic forces of the electric currents flowing through the universe dominate. So you can forget about gravity. And that's why the gravitational theorists had to invent dark matter to make up the deficit in their model. The deficit is there because the concepts that underpin it are invalid. So the question then is, well, what's this huge concentration of mass at the centre of a galaxy if it's not a black hole? Well, one of our team here, Steve Crothers, another Australian, has shown that the theory of black holes is actually full of mathematical holes. A lot of meaningless terms are involved. And this is one of the dangers. You look at a blackboard full of mathematical symbols. Unless the lecturer can explain each of those symbols in physical terms, then there's no necessity to believe anything that comes out of that, all those equations.
Mm-hmm.
So the plasma cosmologists show that the spiral arms of a galaxy are due to what's known as a plasma pinch effect. And that is when the currents, I should say, flow through the universe like twisted pairs. Now, engineers know that a twisted pair of wires is the most efficient way of transferring energy down two wires without loss. And the universe was there first. They did it. I mean, the universe did it. It knows how to do it. Nature never does things the hard way. Now, when two of those filaments, they're huge, by the way, when two of them come close to one another, they interact magnetically and draw each other together until they go into a dance, if you like, around one another, and they pinch together, and electric currents flow from depending on which way you look at current flow, the electron flows goes from the outside to the inside. And so at the centers of galaxies, there's not a black hole. There is a thing called a plasma focus, a dense plasma focus. It's where the plasma is densest, and this is where you get all of these effects which look like a massive object. However, Einstein, or the equation that is attributed to Einstein, E equals mc squared, the one that everyone knows and nobody understands, says that energy and mass are equivalent. Now, in the dense plasma focus, you have a thing shaped like a donut where the electric currents are twisted as tightly as you can imagine around one another, and that's because of all the energy stored in that tiny little thing. It appears extremely massive, and its effect on the bodies around it appears as though it's extremely massive. Another aspect of these that the engineers know that worked on these plasma focuses, and it's the sort of thing there's even a guy here in Canberra had one in his garage. He was a high voltage engineer. He said, "Oh, they're very easy to build." Anyway, this tiny little donut becomes unstable at some point, and it ejects jets along the axis. And this is exactly what we see galaxies doing, and exactly what black holes shouldn't be doing, since they're supposed to suck everything in.
Right.
So the evidence is just staring us in the face that the gravitational model of galaxies is incorrect. But this comes down then to the human aspect in science. And because of the specialization, the way we train people these days, their ability to see the big picture is actually disabled. It's this concentration on detail, like a chicken pecking for seeds amongst the dirt. This concentration on detail that doesn't allow them to see the big picture.
Right.
And as a well-known psychiatrist said, this kind of left brain thinking is the kind that is required for survival on the part of the chicken, but it's the right hemisphere which has a global, keeps an eye out so that the chicken doesn't become somebody else's dinner. Well, it seems that the way we educate students these days in mathematics and that gives them the left hemisphere dominance, which inhibits this ability to actually see what's right in front of them.
Right.
So, we have to change our ways. We have to change the way we train people. The old classical model of education where you did a bit of everything, you did the arts as well as the sciences, is actually the kind of thing that I think we have to return to. And I think a lot of students would be happy with that too.
I agree, yeah. Separating everything has really set us back in a lot of ways.
Yes.
And in one of your presentations, you say that the solar nebula model has no successful predictions to its name. And that sounds like a pretty bold statement. What exactly do you mean by that?
What I mean is it's never been shown how you form a single planet in the vastness of space from a disk. You imagine where the Earth is now, that there's a disk of dust and gas that stretches right around the sun in our orbit. There is no real way to make that dust coalesce to form a single planet. Mm-hmm. And, I attend astrophysics seminars at the research school here at the National University, and we had an expert on the solar system and the planets and planetary formation. And he admitted that you need a different theory for every planet. Now, this shows that the model that they use, that gravitational accretion model, is in serious doubt. But this is not admitted. What happens is that people then, using the left hemisphere approach again, the left brain approach, they go in front of their computers and they build models and try and make it work. And they can make all kinds of assumptions. It doesn't matter. They just add more and more variables. And this is one reason why the Big Bang model has more variables than it has actually information. In other words, it's a failing paradigm. Mm-hmm. Now, with the planets, the thing is that when the infrared telescopes in space began to peer into the clouds in deep space where stars are forming, they were surprised to find that they're forming in strings, like beads on a string. Now, this is precisely what the plasma cosmologist said would happen, because stars form rather like the galaxy forms in pinches along these electrical currents through the cloud. So if you like, you can imagine lightning in an earthly cloud. Well, lightning can form a bead lightning if it's sufficiently powerful. Mm-hmm. That means you get little bright blobs where the channel breaks up. And this appears to be what happens in those molecular clouds in deep space. Now, there is no reason at all to suggest that only stars are formed in that pinch. Any bodies down to any size can form in that same event. And this is precisely the Electric Universe model. Once the lightning fades, if you like to put it that way, gravity then does begin to take over, and these bodies then assume partnerships. And this is why the solar system looks like a fruit salad. There is no gradation of properties from the inside to the outside. They're all individuals, if you like. We're like a blended family.
Right.
And this is important from the view of David Talbot's reconstruction of the recent history of the solar system, and also the incredible amount of research and documentation that's been done by one of our colleagues, Eduardo Cardona, in his Star series of books. And if you want to know what the recent history of the solar system and the Earth and humanity was really all about, I would recommend that you begin to read Eduardo Cardona's books. They're very readable, heavily documented if you want to chase things up, and they make sense. And it was his work that I used as a basis for trying to explain using the physics of the electric universe, because I felt that if I couldn't do that, then we're in real trouble. And I finally managed to do that just a few years ago. I mean, it took that long to figure out how you could actually form the strange things that were recorded and memorized and memorialized by the ancients. It's a picture which out science fiction's any science fiction story, but it can be supported both scientifically now and through the mytho-historical reconstructions.
Right. I definitely want to get into the radically different history of our own solar system as described in this paradigm, because it is so different than what we're typically told. But I'm curious, talking about the way that planets form, that they are formed somewhat suddenly and violently from larger bodies rather than slowly formed over millions of years. Has a planet birthing, as described in the Electric Universe model, ever been observed?
Well, one of the things that we observe with our own sun is that it can eject billions of tons of matter in these coronal mass ejection events, they call them, and at very high velocity. So it's not true that you can't form objects by one giving birth to another. And in the electrical model of stars, this is actually what we expect. One of the reasons why stars have a cutoff in size. The other aspect is that when we look out into space and we look at other planetary systems and we see stars with rings of dust around them, we assume that that is gravitational accretion. Mm-hmm. The Electric Universe says no, that is actually the result of that star having expelled material, and it goes into orbit about it. Now, in the process of expulsion, the forces involved generally give you a backing up of the material so that you'll form one large object or maybe a couple of fairly large objects, and they'll be embedded in a ring of dust initially. And also we have the record of the ancients and their description of the birth of Venus. And, of course, Venus is a very hot object, as if it had been born from a body, from the bulk of the body.
Right.
This fits the electrical model that when a star suffers a sudden change in its electrical environment, it has to adjust. And the best way of adjusting is to get rid of charge, and that charge is in the form of matter, the actual material of the star itself. And so that's what it is. An electrical discharge removes that material. A bit like an arc welder you can weld against gravity. You can weld uphill if you like. Sorry about that.
No worries. We were talking about Venus, and I was going to say Venus is an interesting body in this paradigm because it seems like, according to the Electric Universe model, it's the youngest body in our solar system. And also, I guess, I've heard you talk about some type of charge that can be detected between Venus and the Earth, if I'm not mistaken.
Yes, that's right. Venus, when these objects are born from ejected from a star, the initial effect is rather like two gears meshing, and you imagine, in this case, we're talking about Proto-Saturn, as we call it, the brown dwarf star that became the planet Saturn.
Right.
In the process of adjusting to its new electrical environment within the sun's electrical neighbourhood, it had suddenly to change from being a star to being what it was in effect, a giant comet. And comets, we know, spit material out. This is part of the electrical discharge effect. And it was dramatic in the case of Saturn, because here you've got two stars fighting over its power supply. And Saturn, of course, lost because it was the smaller of body. Now, when this body is ejected, it has a slight backward kick, and this explains why Venus has this retrograde rotation. Also, it explains its great heat. I mean, what do they say, 800 degrees Fahrenheit or something at the surface? It's enough to melt some metals. Also, it has a young surface. Now, the standard idea was, the resurfacing event must have occurred. And the latest one is, it must have been hit by some large body and everything melted. These are just ad hoc stories with nothing to back them up at all. Just a story to try and cover up the cracks in the actual model itself. But all of the facts fit. And also around Venus, you've got this equatorial belt of filamentary scars, which were recorded by the Magellan orbiter with its radar. And those scars are exactly the kind of phenomena you see in an electrical discharge. They're called Lichtenberg figures, the kind of things you see on a golf green where lightning has struck the flag and spread across the grass. It's that sort of spidery effect. And, thick atmosphere like Venus has got, that's precisely what would happen to any lightning. It would split up into long, thin filamentary streaks. And they stretch around the equator, which is where you would expect the main discharge to have struck. So all of the evidence is right there. Right.
Yeah, I love this stuff. And how does this model of planet birthing relate to planet composition? Because we're told of how they're formed in gravity. A planet gets denser and denser towards its core. Might this be different in any significant way?
Well, if we go back to what I was talking about, the birth of stars and planets in a molecular cloud, one of the very interesting effects that you get in that kind of accretion of a body is that the elements are sorted by their electrical nature and the fact that it is an electrical or electromagnetic event. And you get all the heavy elements at the center, and they're cool, by the way. They're not hot. And they radiate their energy away as it's accreting. And you get the lightest elements like hydrogen and helium at the outside. So that becomes the atmosphere of a large body, or oxygen, nitrogen, and things like that for smaller bodies. So this also tells us that stars do not have hydrogen at their center. I mean, it's a crazy idea when you think about it, that the lightest element there is would be at the core of a heavy body, like a star. It's just not so. The heavy elements are all there. They're made just like planets. And this is why when you look at a sunspot, it's dark beneath that glowing plasma sheath. That's all it is. It's the sun's like a ball of lightning, and we see the light tops of the lightning, which is that granular effect. And where it clears, in other words, the discharge goes straight through from above down through that to lower levels. It's darker down there. And you can actually see in some of the best telescopic views that inside that black sunspot is brighter, smaller dots. In other words, that's where it becomes more filamentary. So it all fits the electrical model.
Right.
And when you come back to Venus and that, the ejection of matter from a star or a gas giant or anything like that will come from within the body, so that you'll get the heavy elements. And it's interesting from that point of view that it was only a year or so ago that it was discovered that a supernova seemed to have turned itself inside out. And the scientists were puzzled, why are we seeing these heavy elements first? And the reason is that a supernova is a really catastrophic electrical event for a star. This is what happens. The interior of the star gets shot out. And that's why you see the heavy elements first. These supernova explosions are where the star lights up and as bright as the rest of the galaxy for a short time, is due to the fact that the circuit is suddenly broken near the surface of the star or even in some layers below. And this is an effect that you see on Earth in those high voltage transcontinental power switching yards. If you open the circuit while it's live, all of the energy stored over those 100 miles or several hundred miles of wire, the energy stored electromagnetically around the wire all collapses down on the point where the circuit was broken, and you get that colossal arc that spreads up into the atmosphere. Mm-hmm. Well, you can imagine a star, if it breaks the circuit, what happens to it? That's exactly what a supernova is.
Interesting. Now, you had mentioned material radiating away, and I've heard you say something to the effect that inside a planet, gravity could actually be repulsive, and that's kind of an interesting possibility. How is that scientifically feasible?
This is one of those problems where scientists repeatedly, for thousands of years, have used a Earth-centric view. First of all, the Earth was the centre of the universe, and later on it was demoted. But we still have this tendency to see things from our little cocoon in the atmosphere on the surface of the Earth.
Right.
And, of course, it's obvious that everything that we let go of falls to the Earth. This comes down to the structure of matter, the structure of atoms. And the Electric Universe also notes that there is a tendency on the part of nature to repeat patterns at different scales. Now, at the scale of the atom, if you just suggest, and this is what Velikovsky was hinting at, although he didn't get quite that far, if you suggest that the particles that make up the atom are themselves little orbital systems, then they too can distort and form little electric dipoles. And, of course, in the case of a large body like the Earth, every atom in the Earth and in us is attracted towards the centre of the Earth, or the centre of mass. Mm-hmm. And because the nucleus in each atom is anywhere from 2,000 to 4,000 times heavier than the electrons that are flying around it, the nucleus of each atom is actually offset from the centre. Now, when you do that, as I said before, each atom becomes a tiny electric dipole. But that electric field within the atom distorts the particles themselves. And that's the important part. It's not the atom so much as the particles within it that get distorted. And the distortion is minuscule. It's tiny. In fact, it's so tiny that the gravitational force is 39 powers of 10 less than the plain electric force. And this has been a puzzle. Why is gravity such a weak force? Well, this is the answer. We're dealing with the actual electrons and protons and neutrons that make up the atom in this effect. Now, when you look at it that way, you realise that, hang on a minute, we're all attracted like a daisy chain effect, like a whole string of magnets. You jostle them on a slippery surface and they'll all join, head to tail, head to tail, head to tail. And this is exactly what the effect of gravity is. All of the atoms in the Earth and in us are aligned in the same way, and so we're attracted very weakly to each other. But this suggests it's a dipole force. It's the same as a magnet. You've got a plus and a minus, or a north and a south. And that means that in the case of bodies, celestial bodies, stars, planets, asteroids, comets, moons, you have one pole facing outwards, and it's the same pole in every body. And on the inside of the body is the opposite pole, which is resisting compression by gravity. It suggests that you can actually have hollow celestial bodies.
Very interesting.
Yes. I'm actually working on this topic with some other scientists to try and figure out what the magnitude of the effect is, what the possibilities are as concerning the structure of the Earth and the Sun, because it means that you do not have infinite compression from gravity, which is required by the Big Bang model to make black holes and neutron stars and all the other exotic ideas they've come up with in an effort to create a lot of mass in a very small space. As I said before, the plasma cosmologists got rid of that necessity. The Electric Universe points out that it's an impossibility. It takes you back to the kind of science that engineers like, because they can see how it works.
Yeah. Yeah, that's really awesome that you're diving into that. And I know you're probably more on top of this than most people, but I've heard you reference some of the semi-recent seismic data on the Earth. What does the latest seismic data show?
Well, that's just something that I've begun investigating. I'm not in a position to make any bold statements about it.
Fair.
It's just that the center of the Earth, or the deep seismic signals that are supposed to approach the center of the Earth, do show anomalies, and I would expect that. But I haven't gone into it enough to be able to explain it just yet and be confident of the explanation. But certainly this has to be looked at from a completely different point of view. The idea that the matter inside the Earth is super compressed, all the geological laboratories who use these diamond anvils and that to recreate the conditions inside the Earth are actually mistaken. This view of gravity has a tremendous impact on our thinking about the rest of the universe.
Yes.
And that ties in with the work of the modern-day Galileo. He was dubbed Halton Arp, who also came to the conclusion that gravity on a galactic scale and interstellar scale must be repulsive, not attractive. And that is a rather heretical idea until you look back and you see that in history, even Newton considered the idea. There was a chap who was contemporary who came up with it, Nicolas Fatio de Douillet, who you never hear of. Then a later chap, a Frenchman, Lesage, came up with a similar idea. But in each case, they were looking at particles or something impinging from all directions. And when you have two bodies shielding one another by being close together from particles from a certain direction, it gave the effect of holding them in place, even though they were repelling one another. So, this is important,
right.
Fundamentally important from the view of cosmology, because when you think about it, the Big Bang is essentially completely unbalanced. You've got an explosion, and then you've got collapses and collisions. That's all they've got to work with. But what Halton Arp's work showed is that the universe is not expanding, and he showed that definitively. And so he said there must be something that holds these bodies, the galaxies and stars, apart. So he was looking into this problem, the Sage-type gravity, as it was called, repulsive gravity. But there was no satisfactory answer until the Electric Universe model suggests that it is repulsive. So gravity is long-range repulsive, short-range attractive. If you're close to a body, all of the atoms in your body respond to that body and are attracted to it. Mm-hmm. But once you get beyond the sphere of influence of that body, then you are being repelled by everything else. It gives you an idea that the sorts of things that Velikovsky was suggesting happened in the solar system, which under Newton's theory, of course, seemed impossible, are actually possible. You know, bodies don't collide with one another. They try and avoid one another, which means that it changes the whole game and raises the odds in Velikovsky's favour by an enormous amount.
Right. Well summarized. And let's get into some of those radical changes that may have taken place in our own solar system as a guideline for some of this. I guess the cliff notes of our solar system history is that initially the Earth and Mars were rotating around Saturn. The system changed spectacularly when it encountered the sun. And then we have that axial column of satellites that was formed that's kind of described in Thunderbolts of the Gods. I guess you've also described it in a previous presentation as a kebab kind of setup.
That's right, it's just kebab.
I like that visualization. But how did we get from there to here? Because it seems like such a radical change. I mean, it's probably pretty extreme and hard to fathom for a lot of people who are used to thinking about things conventionally.
Yes.
Can you walk us through how we got from a situation where Earth and Mars were rotating around Saturn to this shish kebab-like configuration?
Okay. My view is that we were satellites of a brown dwarf star. Now, in recent years, astronomers have come around to the idea that life is possibly more likely around brown dwarf stars, you know, planets orbiting very closely to a brown dwarf star. This appears to have been the case according to all of the information we can glean from the most ancient recollections, the stories of the purple dawn of creation and so on. In other words, the light in the sky was different. And this is precisely the colour I would expect if we had been a satellite of a brown dwarf. The other thing is that the electrical model of stars, which encompasses all stars without exception, shows that red stars are stars that are having difficulty collecting enough charge from their surroundings. And what happens in a plasma then is that the electrode, the anode in this case, the star, expands its sphere of influence, and it appears as a red glowing shell, because what happens is the electrons involved are accelerated in this electric field. The bigger the shell, the stronger the electric field, and the more this glow occurs. Now, that glow would occur kind of at the boundaries of what we call the magnetosphere, or astronomers call the magnetosphere, which is actually an electrical plasma sheath within which the magnetic field of the object is trapped. Now, with a red star or a brown dwarf star, it's actually quite huge. For instance, if Jupiter's magnetosphere was lit up, it would appear the size of the full moon in the sky at opposition, and yet it's so distant and just looks like a point of light to the naked eye. But it would appear as big as the moon, or as big as the sun, if you like. Mm-hmm. Now, if you were to look at Jupiter then, all of its inner moons and so on would be orbiting within that glow. And this appears to be exactly where we and Mars were, plus a whole lot of other satellites, presumably like Titan and so on.
Right.
Now, when I came across that idea, it also occurred to me that this is the most hospitable circumstance you could imagine for life to form in the universe, because it's like a cocoon or a womb. Any body orbiting within that glow would receive the same amount of energy per square metre over the entire surface of the planet. And this explains why it is that we had coal and dinosaurs and so on living in the Antarctic and the Arctic Circle. This is impossible, in our present circumstance. The work of Eduardo Cardona showed that this was, it fitted precisely with this kind of story. Now, the problem is, of course, that a star which has this large glowing envelope, electrical envelope, when it meets a more bright star like the sun and enters its heliosphere, which is its electrical boundary, then all hell breaks loose, because suddenly the star no longer has this sheath, so any planets inside would suddenly view the rest of the universe for the first time. Also, the star itself would try and readjust to its new situation by ejecting matter, and that's precisely what it did. And in doing so, it lit up phenomenally. It turned into a nova, what's known as a nova, a star that suddenly brightens by many orders of magnitude. So that's what gave rise to the stories of, let there be light. That was the creation of our new celestial system. Now, the other thing is, too, that in the sun's environment, the star, the brown dwarf star, switches from being a star to being a comet. And we know that comets have what's called non-gravitational accelerations, and that's due to the fact that its mass is changing as a result of the exchange of charge. And it also occurred on the Earth too. The gravity of the Earth changed. But it then gets sort of sucked, if you like a pip from the centre of its little system, and its satellites are left trailing behind, rather like the breakup of Comet Shoemaker-Levy 9, where that formed a string of objects.
Okay.
But we were sitting in the tail of this comet, and that was an electrical discharge effect, and that gave rise to all of the fantastic imagery comes down to us from rock art and so on, which looked like aliens or strange, inexplicable artwork. Mm-hmm. They were attempts to inscribe in rock, in the most difficult way you can imagine, what they were seeing in the sky as being something phenomenal and never to occur again. That was the real creation story. It had nothing to do with the creation of the universe. That's a nonsense.
Right.
It had to do with the creation of a completely new environment. Now, the adjustment on the part of what we call proto-Saturn was to eject Venus, and that was witnessed, and it was described. Exactly what you'd expect. It was the worm Ouroboros, the one that the snake that swallowed its tail. In other words, it formed a ring of matter around Saturn to begin with. But it too fell behind and then became this radiating star that David talks about, David Talbot, in his work. And Mars, of course, was between us and this fantastic apparition of Venus. And poor old Mars, unfortunately, was like a bobbing object exchanging charge between us and Venus, because it would get close to Venus and there'd be this almighty thunderbolt of the gods, and Mars would change mass and drop towards the Earth, and then it would zap the Earth, and they'd move apart again. It would oscillate up and down the column, and gave rise to all of the stories of dwarves and the mother goddess and the baby returning to the womb, all sorts of things like that. All of the inexplicable stories, but they are global.
Right.
The Australian Aborigines, in fact, here have some remarkable creation stories which describe the time when there were two suns in the sky, a greater and a lesser sun, and one of them hid in a hollow log, which was the imagery of the plasma column between us and Proto-Saturn.
Wow.
There's the other aspect of this too. One of the big puzzles when we talk about the formation of the planets is Earth's water. Where did it all come from? Mm-hmm. Well, the answer is that as a satellite of a dwarf star, it is both the best place to form life, but it is also the place where unfortunate outbursts can occur on the part of your mother sun, if you like, because brown dwarfs are known to flare, and in flaring they, of course, are ejecting matter. And so you look at all the bodies in the solar system that have been investigated so far, they all have strata. They have layer upon layer upon layer of material. So the Earth and the other objects tend to have been built up. The surface layers are built up by events that occur, and some of them are quite catastrophic. And, of course, our geological record shows that we've had events in the past where most of the life on Earth was wiped out. And there's no good answer to that. The only answer that the gravitational theorists can have is one of collision. The problem there is, and they talk about the dinosaurs having been wiped out by a collision, it's not sufficient, because dinosaurs today could not exist. They could not lift themselves off the ground. They're just too heavy.
Right.
Just engineering-wise, the ones with long necks wouldn't be able to lift their necks, because even a steel girder with the weight that they had in that neck and head of theirs, it would bend under the weight. So the Earth's gravity changed. Now, you can't do that just by smacking things together.
Of course.
And it was fairly selective too. I think there's even talk now that the heavier ones died out first. Well, this is the kind of thing you'd expect. Also, the mega flora. I mean, we had huge trees and ferns and things at the time, and they're plants that are adapted to infrared light. So all of these things tie together. This is the reason that I'm fairly confident in talking about it, even when it sounds like complete science fiction. All of these tiny aspects fit. And if anyone wants to look at the story in the detail that's required to check these things out, I recommend Eduardo Cardona's Star series, which are available on our website, of course, at thunderbolts.info.
Mm-hmm. Perfect. And that brings up a curious question, because you talk about us having memories of these massive changes in the human record. Does this model affect the way we should think about the age of things like the Earth and the solar system, the galaxy, and even the universe itself?
Absolutely. That's a good question. The radioactive dating was grasped with both hands by geologists when it became available, because it allowed them to become not just a descriptive science, but what they thought a hard science, because they could put numbers on things. But unfortunately, and this is the case when you have specialization, each group of specialists mislead the others as to the extent of their understanding and knowledge. The astronomers misled the particle physicists who looked at the half-lives of radioactive elements by saying, the solar system was 4.5 billion years old. They don't know that. That's just an estimate.
Right.
No one was there. The the particle physicists then led the geologists into thinking that their radioactive decay rates fixed. In other words, you put it in a book of standards, the half-life of this element is so many million years, without any thought to the actual mechanism, because in particle physics there is no explanation for radioactive decay. It is just a statistical thing, something that you work out in the laboratory, and then assume that this is a universal constant. It's not. There's plenty of evidence that radioactive decay rates change, and that also comes back to another aspect of the electric universe. But then the assumption on the part of the geologists is that the astronomers told them that the solar system has been like Newtonian clockwork for billions of years. All of the bad stuff happened right up, very close to the beginning, all the collisions and accretions and all that kind of stuff, because the radioactive decay dating method relies on the Earth having been a closed system. If there's any disturbance, major disturbance to the composition of the material on the Earth, then the dating system is reset. The clock is either broken or it's, it hasn't been working for a while.
Right.
And that assumption, of course, when Velikovsky came along, his work just showed that can't be substantiated, because here's evidence of massive interference in the biosphere and of the Earth. So radioactive dating, the radiocarbon dating also makes various assumptions, so that you have to be very careful in using it. But as for the long-term dating of things like when the dinosaurs lived and so on, you can practically forget that.
Well said, man. I love it. And I guess our time is about up. Amazing stuff. There's so much more we didn't even get to. Hopefully we can do it again sometime. Of course, David is great at what he does, but I think your side of things is more convincing for me personally, so I'm glad that I could get you on. Before we go, please remind people where they can follow up on these ideas and find the best resources for digging deeper into what you're doing.
Well, our main resource is thunderbolts.info. There you will find ways of getting involved yourself. There's a forum, there's means of donating, since it's a charitable structure. Also, we have regular pictures of the day with very good commentary on the latest scientific news from the Electric Universe point of view. And we have YouTube videos which cover those things sometimes in a bit more detail, and by a number of different scholars who are now joining with us in this adventure. And it's the greatest adventure I can imagine.
Amen, man. Excellent. Well, I do love what you're doing. Keep pushing it. You're one of the great minds of our time, man. Take care of yourself out there.
Thanks, Greg, for the opportunity.
You got it. Wow, guys. Wal Thornhill dropping knowledge like it's hot to the touch. I really do love this Electric Universe paradigm, but I still have a hard time trying to walk some of my friends through the idea of the Saturn-Sun switch. They just look at me like I'm crazy, and I personally am still not really satisfied with the explanation of the transition and how humanity survived. I've read the books, I've seen the documentaries. Wal's Proto-Saturn presentation is awfully good, but it seems like a bit of a leap of faith and wishful thinking to me. And I like the idea. I want it to be true, but for me, there's just a little gray area still. But there's so much indoctrination, and so much of our upbringing and education channels the way we think. So what can you do? I am always pleased, though, when I have an intelligent, scientifically minded person leave the door open for hollow planets. I do love that, and I'm glad we got to it early on. Again, wishful thinking. I can't claim with any certainty that the Earth is hollow, but for some of the legends and stories I enjoy to be believable, there has to be a scientific basis there somewhere, even if we're just talking about massive underground caverns, rather than the full-blown balls-to-the-wall inner sun extreme. And see, skeptics call that confirmation bias, as if I'm not able to separate what I'd like to be true from what the evidence seems is most likely. They're not mutually exclusive, and if I had scientist after scientist say, dude, let it go, the data is pretty conclusive on this, I would let it go. But so many people smarter than me think it could be possible. Brooks Agnew, Eric Dollard, Dean Dominic DeLucia, David Talbot, and Wal Thornhill, and even Alexander Koltepin leaves that door open. I know we are dealing with a fringe subset of thinkers on THC, but I think we get more yays than nays, which is exciting. And I know before this show has even been up for an hour, if you guys go to the YouTube comments or the comment section on the Higherside Chats website, I'm very willing to bet you will see comments that say, I can't trust this guy. He's just another NASA shill. He doesn't see the truth about the flat Earth. I guarantee those comments will be there. And I can say that in this wrap-up because I doubt they even got this far. But we need a little bit of discernment with these kind of things, and I don't think Wal can be dismissed like that. And it's obvious NASA is hiding things and manipulating people's thoughts and knowledge about our environment, but if I'm being genuine, I think the secrets NASA keeps are much more likely to be covering up the electric universe rather than the flat Earth. And I've seen some damn good flat Earth arguments. Marty Leeds, who I love and respect, has put out a few videos of his research, and he's firmly in that camp now. But when I think about major areas of cover-up and how they could relate, I see a clear picture forming around torsion field physics, which is this inner tube or donut-shaped field of energy that some say is the key to limitless energy. Well, how can we complete the picture? If we acknowledge that a big part of the big conspiracy is energy grid control, we can start simple and take the Tesla piece and fit that in there, that he was marginalized and suppressed. Then we can take the UFO piece, where they can't acknowledge UFOs because they use this type of technology, and there's a heavy quarantine around anything related to this energy disclosure. Then you have the education system and NASA purposefully compartmentalizing sciences so nobody puts it all together, perpetuating CERN and what they're doing, holding people like Stephen Hawking up on high as long as he keeps talking about black holes and gravity and leaving the electrical component out of it. And that's if he's not just a literal puppet for the reality shapers, or worse, some advanced sentient AI. You know, I used to file that in with the creepy conspiracies that probably are a bit of a stretch, but let's dig a little deeper into this Stephen Hawking thing. Think about the influence in today's scientific community that Hawking has. Now, if the mainstream paradigm is a lie or heavily flawed in places where Wal Thornhill sees it, why doesn't Stephen? If he's being intellectually honest. From that, I get the impression that he isn't. He's a godlike, infallible authority. That's how he's treated. That's the pedestal the system puts him on. And so what, you might say? Well, if they're going to give someone such a position of authority in an area like the forefront of modern science, will they really leave that up to chance? Or would it be advantageous to have a vegetable of a man in a chair whose speak and spell computer can be programmed to say anything you might want it to say? Oh, how the elites' mouths must water over such a proposition. But are there any supporting facts? Well, it turns out there might be. Do you guys realize that he's seriously the person who's lived with ALS the longest? Yeah, what a coincidence, right? I've looked this up, and several sources will tell you that the great majority of the time, a person with ALS is diagnosed in their 50s and is dead within about 5 years. Stephen Hawking is 74 years old, so they say. Here, let me just read this. It basically hits all the points. It's from newser.com, which I've never really heard of, but this isn't the only site saying these kind of things. This is just the most succinct. It's appropriately titled, How Has Stephen Hawking Lived with ALS for 52 Years? Experts call the 74-year-old physicist's long-term survival extraordinary. An ALS patient's life expectancy averages just 2 to 5 years after diagnosis, and only about 5% make it past 20 years, the ALS Association notes. But Stephen has beaten the odds and lived with his motor neuron disease for 52 years, and no one's sure why, though some experts suggest factors that may have increased his lifespan. In today's Washington Post, scientists also don't know for certain what causes ALS in general and are studying genetic and environmental links, the CDC notes. Yeah, trust them. But although the underlying reasons for Hawking's long-term survival are unclear, scientists' thoughts on it aren't. Quote, he is exceptional, neurology professor Nigel Lay told the British Medical Journal in 2002. I am not aware of anyone else who has survived with ALS as long. Now, 2002, the guy said that 14 years ago. Man, you'd think with Stephen Hawking's bright mind, he might apply it to something more personal. I guess he has no interest in why he's the anomaly for ALS. Okay. What also makes Hawking's case unusual is that he was informed of his illness so young. The average age for diagnosis is 55, though Hawking's early onset may have helped him in the long run. Survival in younger patients is strikingly better and is measured in many years, in some cases more than 10. Oh, well, in some cases people live more than 10 years, so Stephen Hawking living 52 years with ALS, nothing to see here. It makes me wonder. So that's creepy. And to add fuel to the fire, there was a time in 1985 where he was so far gone that doctors told his wife it might be time to shut off the life support machines. That would be when he was in his mid-40s, a much more reasonable time for your average ALS victim to die. But he recovered and promptly finished his book, A Brief History of Time, and the rest is history, right? How lucky we are to have such a brilliant scientific mind be so accurate about space, the universe, and reality. But anyway, I was in the middle of trying to piece together a puzzle here. You got torsion fields, free energy, UFOs, false idols like S-Hawks here, and then you have the shape of the Earth itself as possibly a torsion field shape, a donut, basically a ball with holes at the poles. Now, I'm definitely speculating, but I see a through line between all these points that really makes sense. And if I had to put my money on something, it would probably be that these are the big secrets about space, not that it doesn't exist and the Earth is flat. Let's add to this pile, too, the idea of the firmament, that we are in a type of shell or bubble, a very popular idea for the people of the ancient past and the people of the flat Earth community. Could the people in the past have been trying to describe this plasma bubble of Saturn? Is it possible that without the scientific terms to explain it, they called this cocoon, this envelope, the firmament? I don't know, but I could see it. I do think one glaring hole here, to be intellectually honest and play devil's advocate a bit about the electric universe. And of course, Wal's explanations aren't bad or wrong, but if we really have this type of space observation we're led to believe we do, why have we never seen a system in the formations described by the electric universe model? Why don't we have one single example where we can look at it and say, see that planet in the plasma cocoon of star 2X119? Earth's system was like that at one time. You know, there's no examples whatsoever. That sobers me up a bit on this topic, I gotta be honest. But Wal's point is that we can't see through these plasma envelopes. Okay, that is a fair point. I know it's difficult, but we can't find a single example anywhere. I think that is what we need for me to really be satisfied here. And even if we can't see through it, we're told that we see stars form and explode. We've identified hundreds of systems out there, thousands. Have we ever seen one star discharge to another? That doesn't require us to see through anything, you know? But this is a process, and like many things, we just don't have the smoking gun yet. And it's not a closed case, so don't think I'm shitting on the idea, but I do hope we find that type of validation soon, because I really want to be sure about some of these things. Great stuff, though. For me, Wal's scientific side of things is more convincing than David Talbot's mythology and cave art side. Both important, complementary sides of the coin, but if I had to say what moves my needle further, it would be a show more like today's. Love them both, though, and I hope you find it interesting, along with all the implications and threads that I think something like this ties together. But that is going to be it for the month. We made it, and I did a better job with the timing of episodes, I think. And really, not a weak spot to be seen in this month's lineup, in my honest opinion. I don't always achieve my vision for the show, but if someone was asking what a near perfect month looked like to me, it would be something like April 2016. A good diet and health related show, Dr. Richard Jacoby, Sugar and Nerves. Then a pretty unique show with Alexander Koltepin and Sylvie Ivanoa translating. James Corbett and the Rockefeller oil story, a good Conspiracy 101 refresher. Gotta have it there. Ed Haslam with Dr. Mary's Monkey and the history behind the polio vaccine. Talk about a mind blower. And Wal Thornhill with the scientific side of the Electric Universe. The perfect icing on the Higherside cake, I would say. I mean, that is a lineup. There's many, many guests I've had that I love, but if you're talking about the month-by-month package, this one does it for me. Diverse, everyone has experience or evidence to back up their perspective to a healthy degree, I'd say. Everyone made good, convincing cases for their work. Big thanks to all of them, right? Give it up. And I'll have a little more to say in the THC newsletter. Sign up for free at thehighersidechats.com or on the THC Facebook page. Comes out on the 1st of every month, and I'll clue you in on a show I got coming up in May, as well as my thoughts on the episodes we've done and a couple other things. But May, another lineup I think is going to be very solid. There's one I'm a little sketchy on. You know I try to shoot you straight. So there is one I have concerns on. The publisher sent me the book, and I was kind of like, but I think we can make it interesting. I promise. So trust me, I try not to let you down too often. So sign up for Plus if you haven't. 5 extra hours with these guys on top of the archive should be well worth it. But if you can't do that, maybe just share the show or give it a review as a showing of appreciation, or just keep listening. That's really the important thing. This is my bread and butter, but I'm not here to talk your ear off about things you already know. So with that, I'm going to get out of here. And I now declare this meeting of the Midnight Society closed. Your move, Stephen Hawking string pullers and sealers of the secret sciences. Your fucking move.
Lucid dreams are so vivid, 'cause you go to bed at 7 and your brain comes alive, 'cause you hate your 9 to 5. You wake up with a dread and make sure your cats are fed. Did your brain talk to a ghost who moved your coffee and your toast as you listen to the Higherside Chats? You get to your desk and your boss says it's a mess, and your soul slowly grows to a place where nothing grows. When you think he's not around, you insert a SETI sound. The OM says turn it down, and you say it's just the Higherside Chats. Oh, do you think you'll be invited to Bohemia Grove, to a Bilderberg Club? Oh, do you think you'll be invited by a Rothschild to a party on a submarine? Diving down to the center of the earth, through the Marianas Trench, your teeth begin to clench from the sulphurous stench. The mask you're given doesn't fit, 'cause you're not one of them. Starting today, you'll make plans to get away. There's no one to hold you down, and the what-ifs start to drown. Then you wake to the glare of a cold fluorescent stare, and the light winks at you, 'cause its life is almost through, but it's holding on to quit time just like you. It's time for the Higherside Chats.
Hey guys, thanks for listening to the first hour of the Higherside Chats podcast with me, Greg Carlwood. If you don't know, there is a second hour to all the episodes we do around here. Generally, we're able to get a lot deeper into the topics and ideas that a guest is about, so if you enjoyed what you've heard from THC for free, consider signing up at the HighersideChatsPlus.com to get the second hour of the 5 shows I put together each month. I never really wanted to be a paid subscriber podcast, but I really hate the idea of spending airtime promoting some product that's completely unrelated and telling you the best way to support the show is to buy an audiobook or new underwear by mail or something crazy like that. So instead, if you like the show, double your time with it for $5 a month and let's cut out all the other shit. It's half the price of a movie ticket and you get at least an extra 5 hours of show a month. Collectively, it keeps us stable, and it frees me from wasting your time with anything but the show you came to listen to. It's really the only way for an independent, one-man show to make it, and I do what I can so that it's worth your while. Since we started this, I've always tried to use the subscriptions to improve the podcast and make signups more advantageous. It started with just a second hour for the main show, but now we've got a nice forum going where people can get deeper in conversation about the episodes with other listeners, submit a candidate in the guest request thread, or share their own personal projects to get out of the soul-crushing 9-to-5 cog-in-the-wheel life on the entrepreneurs thread. The forum and the plus comments are always the first places I try to go for listener engagement, but it does get harder as the show gets more popular. Because of that, there's also a direct messaging feature that you can use to reach me through the plus site also. But beyond the forum, if you like any of the music I've used for THC, most of it I've hired artists to make, and I provide it all as free downloads to Plus members too. So if you like a particular song you've heard close the show out recently, come get the MP3. I should also mention that if you don't like the idea of paying $5 recurring every month, I get that. You can buy 3 months, 6 months, or a year up front and just be done with it. I have plenty of listeners who send checks and money orders to the P.O. Box too. I try to make it as easy for people as I can, and you can read more about it on the sign-up page. Also, be sure to check out the FAQ help page on the Plus site if you have any questions or concerns about how to listen to a password-protected show on your devices. I've highlighted a lot of great solutions, and one of those would be the iPhone app that just recently hit the Apple App Store. A super kind and talented listener made it for us, and you can use it to stream or download either the free or the Plus show. If you're on Android, I'd use Pocket Casts or Podcast Addict and subscribe to the feed manually that way. I also try to throw in occasional bonus shows or Q&A shows, and I've got a few other weird ideas I might get to try out soon, but I give you all I can for $5, and I hope you'll at least give it a shot if you've listened to a few free shows and you find them unique or valuable. I know there's a lot of podcasts out there, and I'm just one of them. But if you have any questions, concerns, or comments about any of this, please get in touch with us at the HighersideChats team at gmail.com. I also wanted to plug the Higherside newsletter I'm going to be putting out, totally free for anyone who wants to sign up at the main internet website for the show, the HighersideChats.com. You can also get on that email list through the Higherside Chats Facebook page. There's a button there as well. But the reason I'm doing this is because I get tons and tons of emails after a show goes up asking me about how I feel about a particular guest or topic, and the wrap-up isn't always the best place to do that, especially if I have anything negative to say. Sometimes the dust needs to settle. Sometimes I need to hear feedback from you guys first. There are a lot of factors, but I usually have something to communicate to you, and I just don't get to do it. So on the first of the month, I plan to send out a little newsletter with my thoughts about the 5 shows the previous month, and talk to you about anything else that's on my mind or that's going on. And what's probably most enticing is that I'm going to give you some insight into at least one guest I have coming up in the month, which people have been begging for some posted schedule for a long time. I personally think I'd like the surprise. But sign up for the Higherside newsletter. It's free. It comes out on the first of the month, and I won't waste your time with any other emails. And that's it. I appreciate you listening. I try to give alternative ideas and guests a fair shake on a high-quality podcast, expose some deep-level conspiracies without the yelling, and I hope to offer some inspiration that even though the system relentlessly suggests you should follow their blueprint to mediocrity, you can do your own thing and live a much happier life despite all the negativity in the world. So go ahead and treat yourself. Isn't it about